afternoon, everyone. So it's a pleasure to be here at the OCX 2024. I'm Danilo. Today I'm going to talk about the circuit breaker pattern and microprofile, and that's an interesting talk about that. I know how much of you are working with circuit breakers or know anything about the resilience. Does anyone works with that or have this kind of problem on your company or on your team about that? Wait. So before we jump into the main topic, which is circuit breaker microprofile, let's just start from the beginning and talk about what is resilience, which is the main problem that circuit breakers come solve to help us solve that. And talking about that, does anyone want to has any idea or would like to talk about what's resilience for you? Anyone wants to try something related to that? Anyone has any thoughts on it? Oh, that's okay. Oh, that's good. Martin does talk that it's something that you just happens and it shouldn't happen, then you should find a way to solve that. So let's take a look at what is resilience. So getting from let's say the going from for the main word, what does this word means? Is an ability to recover from or adjust easily from to a misfortune or a change. So it's related to something happens, something has changed, and then what comes next. So resilience is all about that. And I don't know how much of you, but resilience is not only about technology. We can talk about people that are resilient, not only that, but let's say, some kinds of engineer or mechanism that is resilience, or we can even talk about a car that is resilience, has resilience between different roads that it's being driven. So resilience is something that can be applied to so many things, and it's a word, it's a concept that we bring into technology, and to talk more about how we can handle our changes, because I don't know how much of you agree with that, but when we take a look at some of the principles of the DevOps concepts, software is alive, so software is changing every day. Every day has a new change. Every day has a new technology. I don't know about you, but I'm deploying every day, and my team is also doing that. So it's always growing. It's always getting new and new features. So resilience might be something interesting to apply in software and technology. And take a look at technology. One of the concepts, or someone that brings these concepts, and I really enjoy his words, is from Son Newman. I don't know, anyone has ever heard about who is Son Newman? Yeah, oh good. He wrote these two books. I really appreciate them. I don't know if you like architecture or if you're working with microservices. I really recommend reading these books. They are really insightful. They really help me to understand more about these kinds of architectures. And at these books, some Newman talks that resilience with microservice architecture intends creating systems that can absorb and recover from failures, providing the ability to scale, evolve, and continue functioning under various conditions. Oh, this is huge, This has a lot of things related to this phrase. It has a lot of things that we can use in our day-to-day work. So let's just take a look at what does that truly means. So the first thing that I would like to highlight here is the fact that it absorbs and recovers from failures. So does it sound familiar for anyone here? Something that absorbs and recovers from failures? So let's think about that your application is having a lot of requests, and the throughput is just growing, and then something starts to fail, and then it has to find a way to recover from it. So this makes a lot of sense. And then to do that, usually we can implement a health check in our application or something like that. So going to the second point of this phrase, the ability to scale and evolve. So as I mentioned, let's think about that we have our application, and then I don't know which kinds of applications do you work for, but let's think about a marketplace application, and let's say it's about to run the Black Friday, and then a lot of clients wants to buy a new item. We have a lot of promotions in our platform, and then we need to find a way to scale it. So think about resilience. This is related to scale our application. This is how we involve our application to handle with more connections, to handle with higher throughputs. And last and not more important, truth under various conditions. So I mentioned about Black Friday. I don't know, anyone here works with marketplaces or any place that sells things or any kind of application that has spikes of throughputs during the day or during the month? Anyone has this kind of behavioral application? So let's think about that. We can have higher throughputs, or let's say your database just starts to had some high loads, and then this is a new condition for you, or maybe it can happen, but your cloud provider can also have some kinds of problem. Then this is the condition that we have to think about resilience. So just talking about that, resilience is just a simple word, but it has a lot of concepts and principles behind it. And basically, I would like to highlight 3 points here. So resilience is basically how we handle failures, how we can handle an increasing workloads in our application, and also think about the different changes between that. So just going to a practical example, let's think about that we have two applications, Service A and Service B. They are different applications. Each one has its own responsibilities. At this example, Service B has his own database, and Service A is requesting Service B using HTTP requests. At this practical example, I know it's pretty simple. No, does anyone has any example in your company that does something like this, having two servers that calls each other using HTTP requests? Has, oh, that's good. Yeah, the majority of you have this. Let's think about that Service B has this kind of behavior during the day. So think about that we have the last 24 hours, take a look at the throughputs of your requests. This is the common behavior of our application. So think about that. This is a marketplace application. Usually we can have some spikes during the lunch, where people, they go out for lunch, and then they get their cell phone, and then they like to scroll down under the marketplace and look for something new to buy. And when we take a look at night, it has a higher load because everybody is at home, everybody is there trying to think about, oh, that's nice, what's can I buy now? So I don't know about you, but usually when I want to buy something new at Amazon or any marketplace, I usually look for it at night when I'm home with my family. So this is the throughputs, what this service B corresponds to it. And let's think about that. At this graphic we have two main spikes. So we can take a look at this time at these two slots of time, where we can see a higher throughputs growing a lot. So just getting some metrics here. The first box, the throughputs just grow from 4 million requests per minute to almost 6 million requests for each minute. And the second box just grows from 2 2 million requests, almost 3 million, to almost 5 million requests. So it has a really high spikes of requests that the service B starts to receive. And this is fine. You know, we can handle with that. It's not a problem. We can just scale more pods or scale more instances of our application, and then we can handle with that. But what happens if our database starts to have a really higher workload, and then some of our requests starts to fail? So this is a real graphic of one of our applications that it just starts to have some problems in our database. And it was fun. I guess I have time to share that, but someone just starts to create an index into the database, and then the table just starts to lock the queries. So this was the problem, that we had to understand what was causing that problem, and until we solve that, our application should find a way to correspond to that. And then just remember about resilience, how we could implement a pattern or a way to implement resilience in your service, and be able to keep responding to clients with some response that will fit with them. So just come back to our example, what do you think that happens to service A while service B was getting all these failures during this time? Just remember, service A is making some HTTP requests to service B. So what happens to service A? Anyone want to try something? Yeah, that's it, exactly. It just starts to fail. So this is the graph of service A. So as you can see, both of them has almost the same throughputs. Not the same, but you can see right here that service A started to fail. And also the errors that service A started to answer also grows a lot. So where is the resilience implemented here? So this is where the resilience comes from. So just comparing both of the service behavior. This is weird that only because service B started to fail, service A also started to fail. And this is a problem. I don't know about you, but anyone here is working with microservices? Yeah. I don't know, but I just give you one example using two servers. Let's think about one architecture using microservices that has, I don't know, 100 microservices, 1,000 microservices, 5,000 microservices. What would happen with this kind of architecture? And I don't know, maybe you that work with microservices, I don't know if you ever heard about this term, which is HTTP hell. Anyone has ever heard about that? Oh, good. So HTTP hell is when you have a microservice architecture, or not only microservice, let's say a distributed architecture that all the services make some HTTP requests with each other, or synchronous requests, and then one service starts to fail, and then because of it, multiple services start to fail with that. And this is not good. This is, I would say that it's the worst thing that could happen in a distributed architecture, because you just start to get incidents with all your teams, and not only that, your operation also starts to fail. So you are going to lose money. The company will start to lose money, and probably, I don't know if you work with any other kinds of area, but if you work with medicine, for example, or in a healthy company, maybe someone can die. So there comes the partner of circuit breaker. So it comes to help you with this kind of behavior. So circuit breaker is one of the partners that can help you to implement a better resilience in your architecture and in your service. Does anyone knows what's the circuit breaker pattern? Oh, some of you know. So just talking briefly about that, a circuit breaker is a component that can interrupt the flow of currents in circuits to prevent damage under certain conditions. So just come back to the San Newman phrase. The circuit breaker helps us to implement, fail to prevent some failures, and also to handle with different conditions in our architecture. And just talking with more simple words, the circuit breaker is nothing more than components that analyze the error in our application. And when something is weird, or when something is not on the flow that we would expect, it works as a semaphore and a fallback concept to implement that. And just talking about that, the circuit breaker has three stats. So it's important to know them. I'm going to show one code example on how to implement it. So the first stats, and the stats that we always want to be on this stats is the closed one. So that means that all the, not all, but the HTTP requests are resulting with the HTTP stats that we expect. Not all of them, but let's say the failure threshold is under this condition, so we are getting more success than failures, and we can set up what will be the range of failures that we want for this implementation. And when our service starts to fail, I don't know when you remember that spike that happens during the launch, that the errors just increase. It just moves to the open stats. The open stats means that none of the HTTP requests will be done to service B. So when the service A is requesting service B, instead of it request a new HTTP request to service B, it will just block it, and then it can trigger a fallback or any kinds of a different approach for that. And when we are on the open stats, there are some requests that usually the circuit breaker uses to test if the service B just got recovered. So the circuit breaker moved from open to half open, which means that, let's say you have 100 HTTP requests, 95 requests will be blocked, and then they will not be sent to the service B, but 5 of these requests will be like a test request that will be done to service B, and then check the status of it. So for example, so think about that. If in these 5 requests, the service B just gets the response with HTTP 200, so that means it was success. Probably the circuit breaker will be moved to closed, and then the request will start to be concluded, and then the service A will be able to call service B again. Otherwise, it will keep on the open stats, and none of the requests will be sent to service B, and will not be sent to service B. So, just talking about that, there are a lot of libraries that can implement circuit breaker. So I don't know if anyone has ever heard about Hystrix from Netflix. There's some people. I don't know if you are using that on your applications, but it's deprecated since 2018, so do not use it anymore. Also, we have the Microprofile Fault Tolerance. So you have seen that people are talking about Microprofile in Jakarta, and Microprofile has his own implementation of fault tolerance. That's it. I really appreciate that, and the example that I will show will be with this kind of implementation. And also there is Resilience for J, which is another open source library that you can use for that. This is pretty cool. I really enjoy that. So these two libraries, they are pretty cool to implement that. So I guess I have more 15 minutes, I will try to show some codes with that. So just to explain that, I will show one application which is using Jakarta E, pure Jakarta E, Open Liberty server-side application, and the implementation with Microprofile Fault Tolerance. Let's get here. It's a pretty simple application, so as you can see here, I have some endpoints in our application. I just exposing three main endpoints. One is the hits. It will show the hits that I have for each endpoint. The second one is the reset. Is a mechanism that I created to oh, sorry? Oh yeah, sorry. This is a problem because I never remember how to zoom in. Is it better? Oh, okay. Sorry for that. Yeah. Thank you for reminding me. Okay, so here I have three endpoints. Two of them is only for helping me to test the circuit breaker. So one is hits that will retrieve the number of hits that I have for each endpoint based on their name. The third one is the reset. It will reset the hits. So what I did here, I built my own logic to count the number of requests that I have for each endpoint. And the point is I just set up one threshold for each of them, and then it can trigger a failure for each. So just come here to understand more about that. I just created this HP hit counter. It's not so complex. It doesn't matter how it will work, but it's a kind of way to create a fake server that will sometimes retrieve a success or a failure hit. So I didn't create two servers and deployed it. I'm only working with one service. And the point here is, I have three. I just take a look at how we implement the circuit breaker. We are using this annotation, the circuit breaker annotation, which has some variables that you need to set up. So just talking about these variables and how you can use that. The circuit breaker is basically one component that's do some analysis for something. So when you are doing some analysis, it's important to get a range of time, a range of requests that you are going to do this kind of analysis. At this example, and how microprofile fault tolerance do that is using a request volume. So let's think about that. You can set up it to under 100 requests. It will make the analysis to understand if the circuit breaker should change his status or not. So think about the first parameter that it's important to know is the request volume threshold. So at this example, I use it 25. So it means that every 25 requests, it will make the analysis for the circuit breaker. The second parameter is the failure rate. So it's the percentage of failure that you will accept from the server. So let's think about that you are making requests from service A to service B, and that's fine for her to accept at least 10% of failure. This is fine. So the server can handle with 10%, it's not a problem. Or let's say that you have a higher priority communication between the two servers, you can just set up it to 1% or less than 1%. The third parameter is the delay. So when I told you that you need to analyze it between a range of something, the delay is the second thing that is important, because you are working with 100 requests, and this requests you need some time to understand when you are going to start to test when your circuit breaker just move from open from closed to open, you need some delay time to understand when you are going to do some test requests and then move the circuit breaker to halfway open. The delay time is this time. So when we think about the circuit breaker, it will take some time to start to test if the circuit should change to close to open to halfway open. And the next parameter which is important is the success threshold, which is the number of consecutive successful requests that the service will get to then move it to close it and everything starts to work again. So just showing some of this application, I will test it with three different endpoints, and let's see how it runs. Oh, it's running. It's almost there, so I should have been running it before the talk, sorry. Okay, let's try. Oh, no. Okay, it's there. Just some live codes problem, just waiting to run it. I don't know if it should be running. Okay, it has just changed. Okay. Okay, it's there. So the host has changed. Sorry for that. So this is pretty simple. The endpoint just retrieves some message. So I can just run here and it will always get the same message. The same for the other endpoints. Each endpoint will have its own behavior, so I set up the circuit breaker to have its own behavior for each kind of endpoints. And here is the other endpoints related to get the hits from it. Okay, we can see that OCX Java community has one, and OCX has also one, because I just sent a request for them. And the magic here is that so far it's not a problem. And as I told you, there is one thing that it's important to know is that when we have a circuit breaker and when it's open, so none of the requests is going to the service we're trying to talk, we can set up a fallback for it. So I will just show how we can set up a fallback for one of the requests. So getting the example here, I have this request that handles the open Java community request. I didn't set up a fallback for it. And I just going to set this configuration here. So basically what it does, so the fallback has two main parameters. One of them is the fallback method. So using Java reflection, it will try to find a method in our class that has this name. So just come down here. There's this method over here that I just wrote helping me Java community. And also another important parameter for that is when it should be applied. So when if you are using any HTTP clients like HTTP3 or RESTs or something like that, you can specify which kind of exception you are going to use this fallback. At this example, I just set up for a runtime and a circuit breaker open exception. It doesn't mean, and by the end, what I need to do is that as I'm faking the HTTP request, I will set this kind of condition for me. So if our key is OCX Java community and the number of hits that we have for this endpoint is equals to, it will just throw a runtime exception, and then instead of returning some error or doing some requests for it, so returning what the server would do, it will just go to the fallback and cause the fallback that we set up in our fallback annotation. So let me see. I need to run, it's only 3 minutes left. So just checking the endpoint. So for the Java community, the hits is under 0, because I just said I'm using the dev modes on Liberty, so it has our auto reloads, and when I change the codes, it's just auto reload the codes and reset the JVM. So as we set up for when the hit counts it's 2, so it will just send one exception, and then we'll call the fallback. So I'm going to do 1 request, 2 requests, and on the 3rd request, so the hits count is 2 now, it will check that it's 2, and then it will throw an exception, and it will return our help me Java community. I don't know if you are able to see that. So how does it work? So the point is, it uses the Java processing annotation to do that. So before the method is called, it verifies the fallback annotation and the secret breaker, what's going on. So with the secret breaker, it's just got the results of getting an exception, and then instead of doing the request, now if I call it again, it will return the right request response for that. So basically, this is the important thing. There is a fourth parameter which we can use for circuit breakers, which is the skipping. So if you have only specific exception, that even if that you want to make the call for the service B or for the second service, this annotation skip on will just ignore what's going on with the circuit breaker, and will keep doing the request even that it's retrieving an exception from it. I believe that's for the show the code. That's all. So I just come back to the presentation. Okay. Yeah. So I believe this is all. I don't know if anyone has any questions. I had to run with the coding example to get some questions time. So if anyone has any question, anything to talk about that, that's the time. Thank you. Yeah. Yes, yes, that's possible. So when we were working with Microprofile, I had old version from Microprofile. I haven't seen the new version, which is 4 plus. I'm using the version 2. I'm sorry for that. But when you think about, for example, resilience 4J, it has the slides window to verify the circuit breaker with this parameter. I believe that the new version from Microprofile Fault Tolerance has this implementation. So this, maybe I would say that this is the main important parameter when you have a slides window instead of having a request volume threshold for that. Oh, that's a pretty good question. Yeah, yeah. Yeah, exactly. So the question is, how do you define the parameters for your circuit breaker? I can tell you that it always depends, as you mentioned, that you can have some service that has a low priority on your flow, and then you can have a higher failure rate, and that's fine. And also there's no, it depends on a lot of variables. I like to think about what is the priority of your of that HTTP request for your flow. Otherwise, for example, you can just set up as a fallback to, instead of doing a HTTP request, you can just send an event message using some broker or like Kafka or SQS, and then process it asynchronous. So you can have this kind of behavior. So I like to think that it's a mix of the priorities of that service in your flow, and also how you can handle the fallback. So if it's possible to work with some message broker, or let's say if you can work with some static API, for example, not having the real-time data, but you can do a request for a S3 bucket which has the response in a static way, but it might not be a real-time response, so you can get some dirty data or some data that's not updated. This is fine. So it's important to understand what is the flow that you are doing. So for example, for a payment system, I would say that try to use a message broker and try to do it the flow in a asynchronous way. But let's say you're just trying to get the let's say the address for the user to do something, and then the service responsible for that is failing. If that's not so important to have it in real time, you can just reach a static API, or you can even just say, oh, okay, this information is not so important now, so this is fine to not retrieve that. And then even if that, you can just set the circuit breaker to go to the closed state on that for that service. Oh, sure. Yeah, yeah, yeah. This is another approach. So you can also implement circuit breaker for your database. I have been using it with some of our microservices. So this is not only about HTTP requests. It can also be about your database. I would say that everything that's also of your service. So what's also of your service? Everything. You can implement a circuit breaker and think about how to do that. So, so oh yeah. So yeah, that's a good question. I would like to think that know it's not so good to have think about if you are working with only one monolith and everything is working. This is fine to just handle exceptions in a monolith, but when you are trying to get some information for a third-party service, even that is a service from a team that is working on the sides of your team, we never can trust that. So it's important to implement releases itself to think about that. Okay, I must be here working in this in the architecture, and not to, not to just and not just throw an error to the architecture because another component, a third-party component, is failing. So we need to be able to handle with the problems and not just expand it, or let's say send it to other services that are requesting us. I like to think about that. Resilience is much more about that, how we handle with errors in our architecture, and try to encapsulate the errors in less layers than the in less layers possible. So think about that. You have one architecture, you have, let's say, 5 microservices requesting each other. If you are able to handle one exception in only one microservice, and let's say all the other 4 microservices without knowing that error, that's good. This is all about resilience. So not, I would say that the ability to not throw the error for all the service is the main concept of resilience that I like to think about that. So think about the example. If you are able to handle the exception in only one microservice and all the other microservices still keep running and working, that's good. But otherwise, if you just throw the exception for the next service and then for the next service, and then because one thing is failing and the 5 services failing, so that's not good because everybody's failing. That's
So I understand it that way that basically every time I call a different service, I should think about implementing resilience if it's possible.
yeah, if it's possible. I would say that yes, that's a good process for sure. So, any other question? That's so. That's it. Thank you all for being here and enjoy OCX.